Welcome to my channel, The Seiko Physics. In this video, I'm going to discuss rectangular components of a vector. So the projections of a vector along the axis of rectangular coordinate system are called components. So here, it means for a given vector A can be described by its components. So in this x and y axes in the coordinate system, if a vector A is given, then the projections along x-axis is ax. So ax is the x component of vector A along x-axis, and ay is the y component of vector A along the y-axis. So whenever we are given a vector A, we can just draw its projections and we can describe it in terms of its components. So in vector form, we can write down A equals ax vector plus ay vector, where ax is the x component of vector A and ay is the y component of vector A. So these components can be either positive or negative. It depends that A is lying in which quadrant. From the definition of sine and cosine theta, we can find out the magnitude of ax and ay. Cosine theta is defined as a base over hypotenuse. So from here we can write ax will be a cosine of theta, and sine theta is perpendicular of a right angle triangle to the hypotenuse. So ay will be a sine of theta. So if I want to find out what is the magnitude of A, so here in this right angle triangle, AX is the base, AY is the perpendicular, and A is the hypotenuse. So if I use Pythagoras theorem for this right angle triangle, where this is AX, and this is AY, then I can write down A square will be AX square plus AY square, or A will be square root of AX square plus AY square. So this will give us the magnitude of vector A using its rectangular components. So for the direction, we need angle. So usually we denote it by angle theta. So if this is angle theta here, then I can use the definition of tangent theta, AY over AX. Or here I can write down theta will become tangent inverse AY over AX. So angle will give us the direction of a vector using its components. So there is another method using adding vectors. There are a few steps to do that. So the first step is find the components of all the vectors in some coordinate system that is appropriate for the problem. And then after that, we add all the x component to find the resultant component in the x direction. The same way, we will add all the y component to find the resultant component in the y direction. And then we will use the Pythagorean theorem to determine the magnitude of the resultant vector, which we just did for the previous vector A. And then use a suitable trigonometric function and the components of the resultant vector to find the angle. So whenever we will talk about the angle of a vector, it means its direction of the resultant vector, which and usually we take it with the positive x-axis. So with positive x-axis. Determination of a vector from its components. So before, what we did, we were given a vector A and then we used its components, and here we determine a vector from its components. So if there are two components given, ax and ay, then how can we find the vector? So we use the same Pythagorean theorem here again, because this is a right angle triangle, and from the right angle triangle we can write down OP square will be equal to OM square plus MP square, or in terms of magnitude, A square will become equal AX square plus AY square. Or I can write down A equals AX square plus AY square. And using the definition of tangent theta, I can write down perpendicular over base, which is AY over AX, and theta will be again tangent inverse AY over AX. So this will give us the direction. Thank you so much for watching.